Area 419 just came out with dies. You're going to want to check them out. That's what we're going to cover in this video. Gavin here from UltimateReloader.com. I'm here with Craig Arnson from Area 419. Thank you for joining us, Craig.
Thanks for having me, Gavin. I've been dying to come here and talk to you about this.
Yes, this is a big day. We're talking about the all-new dies from Area 419.
This is the Zero reloading die. We're starting with our M series. We'll get into what that means in a bit. Zero is our reloading pursuit of Zero. We wanted to have a press with zero variables, zero run out, zero slop, zero play, in a pursuit of ammo with zero variability. Now we know that zero is an impossible standard, but that doesn't mean we can't chase it.
As engineers would say, you can get close enough, right? Okay, so let's talk about the problems Area 419 was addressing in this whole reloading die problem domain.
Sure. So the way this really got started is as we were building and testing the Zero, I realized very quickly that we were doing as much die testing as we were press testing. And that got me into a train of thinking about dies. What should they be? How should they be? What are the variables we're finding in dies? And how can we eliminate those in a die ourselves? Fast forward now 2.5, 3 years since we started testing on and pushing out the Zero. We've also worked with a lot of customers in that time. Somebody buys a press and we become a de facto, hey, I've got a problem with reloading. What can you help me with?
Right.
And we commonly run into problems that customers have, whether they are a seasoned reloader shooting at a very high level with very exacting standards that really have some little things they're trying to sort out, or that person who for the very first time is trying to reload or especially reload a high precision piece of ammunition.
Sure.
And as we catalog those problems, we kind of see the same things pop up over and over. So when we set out to design a die, we wanted to take that checklist of problems people have, solve all of them, or as many of them as we possibly could, and do so in a way that doesn't introduce any unnecessary complication for us in manufacturing so that we can create a very consistent product. And we also didn't want any additional complication for that reloader. So whether you are somebody who's very seasoned shooting at a very high level, or you're very green trying to learn how to reload at a high level for the first time, we've built a die that we believe is the most well-featured, the most complete in the way that it functions in the sizing process, and easy to use that's ever been made.
Okay, so let's talk about one of these difficulties.
Absolutely.
One of the things I've run into, not only myself, but with other people, I've even modified lathe dies on my lathe, is head spacing.
Sure.
And you guys have already come out with a shell holder kit.
Sure.
Got different shims that gives you different options for sizing. But with this die system, there's kind of a different approach.
Right.
And that gives you even more control. Why don't we talk about that whole head spacing problem and solution?
Absolutely. So when we're sizing, we like to see the top of the shell holder meet the bottom of the die. This gives us as consistent as you possibly can get in the chamber size. Chamber size being from wherever that the bolt face is, or the facsimile of such on the shell holder, to the shoulder of what is being sized inside the die.
Right.
So on a standard 7/8 die, we have our modular shell holder system, which allows you to control where that bolt face or the facsimile of such is on the bottom. What we're doing here is actually allowing you to move the chamber against a fixed point.
Right.
This gives us the ability to create a micrometer headspace adjustment in sizing.
That's right. You heard that. Micrometer adjustable headspace adjustment. Instead of swapping out dies, or instead of cutting down dies on someone's lathe, you can now
or having
dial
to back
it.
them out and kind of float them in space.
Yeah, and if it's floating in space, then that's going to lead to less consistency with regard to that cam over or hard stop.
Right.
I noticed when you set up the die, you had a little bit of a compression going on
Absolutely.
there. Just to make sure that things are
We
coming
are
up.
absolutely there. We are absolutely against it, because I know that we can control the sizing of the die based on how much space we allow there to be in with the micrometer. We've all used micrometer seating dies at this point. They're very, very common. They're a great tool. I wouldn't seat without one.
Sure.
But that simplicity and control does not exist in sizing was something that we knew we could solve. You know, we figured out how to construct one of these things in a way that we can retain all of the strength and rigidity we need to do appropriate sizing and give you all of that feature.
Okay, so there's another aspect of sizing that's also addressed here, and that is dimensional correctness.
Yeah, this is a big one. So as a guy who's done a lot of reloading and shooting in the PRS community, after I reload a piece of brass a handful of times, whether it's 2, 3, 4, it's really common to start to get a little bit of stick when you get to the top of that primary extraction. What this often comes from is inappropriately sized brass around that web, or like the 200,000th line if you're looking at a reamer spec. The reason this happens is if you look at most common chamber reamers, at that 200 line, you are cutting to a spec of 4705, 4708, just under 471,000.
For the 308 family of
on your
cartridges.
your Dasher, your GT, your Creedmoor, they're right in that ballpark.
Yeah.
Typically, your sizing die, if you were to get out a pin gauge and you buy a sizing die from any of your major manufacturers, is going to be at very least 471, meaning it is the same size or even potentially larger than your chamber, especially if you are shooting with a factory chamber or a chamber that's 1,000th or so oversized, which is very common.
Which fireforms it to too large a spec, right?
Yes, so it's fireformed up. You need to size it down, but if you can't because of the dimension of your sizing die, very quickly, just a couple of reloads, you're going to start to get that little bit of interference between the web and the mouth of that chamber. So we are sizing down to a true factory spec on brass at that 200 line that's going to allow for nice, clean extraction without that sticky bolt problem that you might find when you're running your bolt. Whether you're shooting in PRS and you don't want to break position, or in F-class or BR and you're not trying to break the seat that your rifle has in your bags or in your rest. Smooth extraction is something that we shouldn't have to live with a compromise there.
Right.
There's no excuse for a sticky bolt.
Yeah.
The reason, though, that you often find it is inappropriately sized chambers in sizing dies.
Okay, gotcha. And then the last thing in that whole equation of sizing is
the neck
tension.
Yes. I have long been a proponent of the idea that your neck sizing should be done from the inside of the neck, and it should be your last step. A common way that people will do this is they'll have a separate die on their turret that is a mandrel die. Buy them from K&M or 21st Century. They're good products. That's an extra step that I don't think is necessarily required. A lot of dies may have a pull-through expander, but oftentimes it is a ball or a sphere or an oval. It's a fairly small item, and what we know is if you're not fully supporting that case as that mandrel comes through, fully supporting that neck from the inside, you're not getting an appropriate square size.
Sure.
So when we went into a mandrel, we wanted a mandrel. They are all precision ground, so they're very round and very on size. And the bearing surface on that pull-through expander is quite long. And this means that whether you are loading something with a shorter neck or a longer neck inside your cartridge family, our bearing surface of our pull-through mandrel is long enough that you are sizing that entire neck at one time, which is going to give you a more consistent, more repeatable, more square size inside that neck.
And with that, you get all of the dimensional correctness, all of the reliability that you're going to look for.
You've got the headspace that you need. You've got the neck that you're choosing, and our mandrels are interchangeable. We'll sell them. They all come with a mandrel that's going to get you right at about 2,000 neck tension, and we will have mandrel kits available where you can get a little less or a little more neck tension. And then the dimensional accuracy of the chamber of the die. We're cutting all of these with reamers. I think boring a die is fraught with opportunities for inconsistency. So we're taking the additional step of doing reamers for all of our die sizing chambers.
Nice. Okay, so we've got correct internal dimensions.
Correct.
We've got hard stop always.
Yes.
With
hard on hard.
With the ability to micro adjust headspace. We've got 1 1/4 threads. Tell me about that real quick.
So we needed the additional real estate diametrically to be able to put these features into a die. And what that means is we wanted a sizing chamber that had enough external support as well as space for it to be moved and managed inside the die. So all of our M series, M being the micrometer, all of our M series sizing dies are 1 1/4 thread. The 0 is available. They all ship with a 7/8 head, 9 stations. We also sell a hybrid head, which is seen here, which is 4 1 1/4 and 4 7/8 die slots, as well as we sell an 1 1/4 turret head with 8 1 1/4 heads all the way around. Your rock chucker, if people aren't aware and they have a rock chucker, it's set up for 7/8 out of the box, but that little black insert that you screw in, that thing comes right out. You've got an 1 1/4. You've got an 1 1/4 press there. So 1 1/4 is less common in the die world, but we thought it was the right move for what we were trying to accomplish in the system.
Yeah, No, that totally makes sense because the room has to come from somewhere to accommodate those modular parts. And
we weren't going to sacrifice
components.
strength and structural stability
Yep.
to jam it into 7/8.
Yeah.
Now, we're going to have our S series die at some point in the future, and it will be a 7/8 die. It will be much more traditional. You won't get the micrometer adjustability and headspace, but you'll get all these other features in that. So that's something that will be coming in time. But if you want that headspace adjustability with a micrometer, this is the only show in town, and we think we've done everything we can to make it be exactly the right way.
No, I love it. Talk to me about the hydraulic pressure.
Okay, so when you are sizing brass, you're using lubricant, or at least I hope you're using lubricant, or else you're going to be finding a stuck case removal
Ripped
kit.
off case rim, right?
Right, and when you're doing that, and you have that lubricant, they are all some version of a solid or a liquid based.
Yep.
Liquids do not compress.
Right.
That's why hydraulics exist.
Yeah.
And when you're sizing and you have that at the outside of that neck under pressure, you're creating a sealed chamber with liquid between your shoulder and your sizing surface for the shoulder inside the die. So, as we were going through testing on this, leaving no stone unturned, and this is a feature that is in other dies. You'll commonly find a relief hole in other dies around that shoulder. That's another feature that we put into these. So in our sizing sleeves, they all have a bored hole and a relief so that as material builds up in there, it can squeeze out, get around. It's not going to clog up your die, but it creates a more consistent contact between our internal sizing shoulder and the shoulder of that brass.
So it's better for consistency. How about things like dented shoulders? Because if you get enough
we've all created hydraulic dents.
Right.
And the number one reason for that is somebody using too much lubricant.
Sure. Yep.
But even in a situation where a reloader's not doing everything exactly right, we wanted a tool that would give them as close to a perfect result as possible, even if they weren't perfect, because none of us are.
Yeah.
But everything that we can do on gear to help relieve some of those issues and create a more forgiving system, that's what we want to do.
Okay, so that brings us to the last major feature, and that is the primer flicker.
Right. Again, this is not a feature that is new or unique to our dies, but it's one that we really like because as the prevalence of small primer pocket in 308 base cartridges has lit up, the small primers really like to stick to the end of the decapping pin.
Yes.
If you look at an anvil in a primer, it is a bell-shaped, which creates a nice taper location for that decap pin to stick in. And as you pull that piece of brass out of the die, you might get drawback, and that primer wants to stay attached to the bottom of the case. First time we encountered it was loading 223 on a Dillon.
Yep.
And we ran into all these problems of when you try to go from station 1 to station 2 on a Dillon, and you've got drawback and there's still a primer in the bottom, it doesn't go well.
Right. Right. And the X10, the new Frankfurt Arsenal press, has 2 stations for that reason.
Yeah.
It has a primary, decapping and then a secondary decapping.
That primer has to go away.
It has to go away. Yep.
And a great solution for this, and one that, again, is not new to us, but we wanted to integrate into this product, is some spring tension where when that primer lets loose from the primer pocket, a little bit of spring pressure and that shock to throw it off goes an enormous way.
Nice.
So we don't want primers hanging out. Once a primer is spent, we have no use for it. So we're going to flick it off of the decapping pin and into your primer system.
Well, I haven't actually used the Zero M Series die. Why don't we get it set up on the Zero press, and I'm going to put it through its paces.
Let's go for it.
All right. So here we've got a couple things.
Yep.
We've got everything that's included with the M Series die in a particular chambering, and then we've got a complete die here that's fully assembled like you would get it.
Yeah.
Okay.
This one we're going to put in the press, and we're going to use it. But as a little bit of how this thing goes together and how it works, it starts with the core of the system, which is the sizing sleeve. These are reamer cut. This is 17-4 stainless. It's been nitrided. This is the core of the part, and you can see the little hydraulic relief if you look closely here.
And the nitriding gives you some low friction characteristics and long wearing characteristics.
It helps with lubricity both against the brass. Brass itself is actually really abrasive. It also helps with the movement of the sleeve inside its home here, inside the lower body.
Yep.
So when we're assembling this thing, this lower body, this is externally threaded, 1.25 inch. Again, it's all 17-4. This drops in.
ID and OD machine at the same time or same setup. That
yes,
kind of thing.
all these are run all together, all the same. So nice tight fit there. The mandrel drops in, again, precision ground, steel mandrel with a matching male taper here, female taper here, so that when we're pulling down and neck sizing. We get a nice square alignment.
You guys just love your tapers, don't you?
They're great. I mean, when you need them, you absolutely need them.
Yeah, they're magic.
We then have the upper body, and inside this we contain the stop that meets the micrometer for your headspace, as well as a small spring-loaded cap that pushes against, at the top of the stroke, the decapper, and we'll throw that guy out. So this would come together. If you're a customer, there's no reason you would ever have to do this.
Sure.
You certainly could you certainly could to clean it, or if you want to swap out one of the inserts, because these can obviously be changed from part to part. So the die is, at its very essence, modular. And then obviously the micrometer top, and this guy is a little bit of a, I wouldn't suggest you take this thing apart. This is a very fine thread, very tight fits, but it certainly can be done.
And you shouldn't need to, because you're going to swap out the sleeve, most likely.
There's no reason that you would ever have to do this. And she goes together. The decap pins are removable, and you can buy them loose.
Comes with an extra?
Comes with an extra. We don't think this will be a high-use, high-breakage decap pin, but if anything can break, it certainly will.
Sure.
And we have provisions for wrench on the decap pin itself, as well as on the top of the mandrel. So when you need to remove or replace a decap pin, you have a place to hold it, and there's no reason to get out a channel locks or pliers or something to change the decap pin.
Included.
Tools included.
Love that, including the lock ring die.
That's correct.
Yep.
That's correct. The dies also, if you choose to order one with a shell holder, this little captured system all comes together. It just replaces the retention ring on the top of your ram. This is obviously a 0 shell holder. We will also make these shell holders for traditional click-in.
Nice.
So your standard shell holder look like you would find on the bottom.
With the boss.
It's ready to go. We are releasing these initially only with the 0 shell holders. We want to take our 0 customers first. Appreciate that loyalty. And then in time, these will be available in the traditional sense. You do need to use one of our shell holders with these because of the larger rim.
Right.
We want this larger rim to be what ultimately contacts this lower body or this outer sleeve.
Yep.
So our shell holders are a requirement for the M Series die.
Makes sense. So why don't we get the die on the press, and then I'll take over.
Let's do it.
Okay.
So as I'm setting it up here, the shell holder screws onto the top. This is as simple as it can be. As you get to tight, you want to align, obviously, your mouth forward, and this is going to be captured in space. This is not going to rotate or move on you. I like to have the mouth pushed out just a little bit because this is the side of the press I load from.
I like the generous mouth too. Kind of auto aligns.
I don't want to fight with putting brass into a press. There's no reason for that. So as I screw it in, run the ram up just like a typical die. As I get to bottom touch, I'm going to make sure that the micrometer's out fairly far because we're going to set that depth in a bit.
Sure.
Screw in, get to touch on the bottom, run my ram down a bit, give myself a little more screw in so that I get that nice firm connection that I want, and drop in my lock ring. Come in.
Yeah, these lock rings are interesting because they've got the teeth on the inside, and this is the same pattern as with Maverick, is it?
It is. And it's also the same pattern up here. So once you set this lower body into your turret, if you wanted to change your internal sleeve or take it apart and clean it, you can take it apart from the top.
Nice.
Everything's captured, so you just pull this top part off. You can get your sleeve out, change your sleeve, or clean your sleeve, whatever you need to do.
Gotcha.
So this lower body can remain fixed.
So at this point, the ram is up, and you've already established how much clamping force you want
I've
there.
set the lower body, basically. And now with the ram remaining up, I'm going to run down my micrometer until it stops.
So the sleeve is going down internally now.
Yes, it's now coming down. Really, the sleeve stop is what's coming down because of spring pressure. The sleeve was already down. There was just space to be had.
We're going to meet and compress slightly.
Now we've got hard metal on metal connection between the micrometer itself, the internal portion that the micrometer pushes onto, and then the sizing sleeve.
Okay.
At this point, with the sizing sleeve all the way down, this is probably going to oversize your brass. Not by an enormous amount, not by an amount that's probably going to get you in a lot of trouble, but you're going to get 8 or 10 thousandths of shoulder bump here depending on your chamber. It's more than you want, but it's not catastrophic. It's not 20 that you might find with some other dies if you get hard to hard. From here, I'm going to take a guess based on chamber. If we come out 4 thousandths, so 1, 2, 3, 4.
Okay.
This is probably going to give us a size on your dasher brass. I've set it to 0 here on our comparator set. Let's size some brass.
Okay, I'm going to jump over. Okay, so to start off, we're started with annealed brass.
Absolutely.
I anneal every time with the amp annealer.
As you should.
Going to give us less spring back and just enhance longevity and consistency overall. Okay, so I'll just 0, and we'll use the same 0 across multiple pieces here. Let's see where we're at. So we're at -3.5.
Yeah, so we're bumping maybe a little more than we want. So you can back it off about 2 thousandths there.
Yeah, and if we're 2 or within a half, I'm going to say.
I like to bump it 2. Some people might like a little less. Some people might like a little more. So compared to that -3.5, you should be right now.
Yeah, we're within a half.
We got down right to 2.5 of bump.
I'm going to back it off just a little bit more. We'll do one more just to see where we're at. That's nice and positive.
It is. You're
not going
absolutely
anywhere.
getting to a stop. You know you're there. There's no missing what's happening here.
Yep. There we go, -2, right on the dot.
That is the simplest headspace dialing you can do. And that was really our point. And now you know, let's say you get a new chamber. Shoot out your barrel, it's just 6 Creedmoor, you've got 1,600 rounds on it, whatever. You get another one. And the reality of machining is, let's say that chamber is 1,000th longer or 1,000th shorter.
Yep.
Pretty easy to deal with here. When trying to chase that 1,000th or that 2,000ths via other means can become meaningfully more complicated.
Different types of brass with different thickness, all sorts of variables. Why don't we next take a more detailed look at the internals?
Let's do it.
So check this out. We got a really cool CAD rendering from Area 419. You can, on the top here, see kind of a cross-section of the entire assembly assembled, and then we've got this exploded view. Why don't you walk us through kind of the exploded view, each part?
There are 14 parts here.
Okay.
This is a fairly complicated product, and the reality is at $500 for your die with your shell holder, it's fairly expensive. But what we've put into this is every feature that we think should possibly go into a reloading die, and we've done it in a way that is user-friendly without needless complication. The way this comes top to bottom is we've got our micrometer head, very fine thread. We have graduations for what each 1,000th is up top, and then we've got various reference marks down low.
Thank you for the various reference marks, because some dies you have to have, at a 360 clocking, right, to see the scale, or at least close to that. And here you can kind of set it, hard stop, and then you're going to have a mark that
you're going to have something pretty close.
Yeah.
And if you want to be the guy that gets a Sharpie, fine.
Yeah,
little acetone will take something off, and that's perfectly fine. So we start with the micrometer head. We also have just in here an O-ring that simply sets the appropriate amount of tension around this. So we could operate without it, but it's like a nylock nut.
Holds
basically.
it in place a little bit.
Absolutely.
Yeah.
We come further in, and we've got this upper body. This upper body attaches everything to the lower body, the threaded portion, as well as houses 2 individual parts. One is the go-between, or what sets between the sizing sleeve and the micrometer head. So that is your metal-on-metal, hard-on-hard connection, top to bottom. And then nested inside that piece is the force applier for the spring that does the primer flicking.
Gotcha.
As you were sizing here, you could hear the pink as you go through, and that is that primer leaving with some force the bottom of that case, running through the ram and down into our primer catch system. So you're hearing that go away, and it's kind of just a satisfying thing to hear every time you pull the handle. So we've got those pieces. Those are both driven by springs. The primer catcher with a spring, or primer flicker with a spring, because you want it to go away. And then the sleeve stop with a spring, just so that you can kind of feel it. We didn't want the thing jiggling and dancing around in there. So that's really just a product experience. It's nice that this is all captured. You don't get a bunch of rattle when you shake it. We then move to the mandrel itself. Again, this is a piece of steel that has been precision ground. We then nitride that, helps with hardness, helps with durability. And we were very careful to construct the mandrel in a way that when we send it to nitride and it reaches that heat, we're not getting warping. So we're getting a very straight, very hard, very consistent, very round mandrel that again seats against the sizing sleeve via taper. When you pull, everything's square. The sizing sleeve itself, the heart of the system, and then finally the decap pin, which is replaceable.
So there's a pin body, and then there's the tip here. And that's what we use these wrenches with on either end to tighten and loosen.
We want you to be able to install or remove a decap pin with simple tools that are available. They're part of the system. They're in the kit when you get it.
So I'll have to say I do like this design where you've got a threaded end here, because what you'll find on some reloading dies is you have a collet and a pin. And inevitably, eventually, that pin just falls out. And what happens if the pin, like on a progressive press, if that pin falls out and you continue loading, right? You have to try and find it, because you might not even be depriming.
A lot of problems very quickly.
And so positive retention.
Yes, and the problem is not missing your deprime. It's when you go to the next station, it's time to prime, and there's already a primer there. That's when you go from inconvenient to very quickly possibly dangerous.
And I think I just discovered something here. If you look real close, there's a tiny little taper there.
You sure did. You found it.
Of course.
This is making sure that when that comes into the bottom of the die, we want it to be square. There's nothing worse than a decap pin that does not point straight down. And finding, whether you're a milsurp guy and you find the burden or the boxer primed cases where you've got the dual holes and you pop it in.
Beardan.
The Beardan, they're not great. But having a decap pin that is square and true and directly in the middle and pops that out with simplicity, small design feature, nice benefit.
Totally love it. So you shouldn't need to take apart your die to this level of detail, but I hope that it helps you all understand how this die comes together and how all of the features relate to each other. Now, Craig, before we kind of conclude this video, is there anything else that you want to maybe allude to or mention?
So after you size, there's a logical next step in brass and seating. And it's fairly reasonable to think that this same press body and this die body and these parts could be reconfigured for a micrometer seater.
That would be very interesting, wouldn't it?
It's logical that we would do so.
You all should be subscribed so that you don't miss any of those possible occurrences in future videos, cool loading stories, and so on and so forth. So if you want to know more about the Zero M Series dies from Area 419, go to area419.com.
Pricing and availability. The die with the shell holder is going to be $500. You can also buy the die without a shell holder for $450. Shell holders would be $60 on their own. Buy it as a kit, save a few bucks. But if you already have a shell holder, don't need another one. Let's say you buy a Dasher and a GT. You don't need both shell holders because they're the same. Those can all be purchased. They will, in the very short term, you can buy one right now at area419.com if you're a Zero owner and you have a Zero press, because that's what the shell holders will be set up for. The cartridge availability immediately for pre-order will be 6 Dasher, 6 GT, 6 Creedmoor, as well as 6.5 Creedmoor.
Nice.
308's coming very soon. And we are going to initially work through your common short action cartridges. We're PRS guys. We're going to cater to the PRS first. Very sorry, F-Class, and as well as a larger Magnum hunting community. But know that these dies are built in a way that we can run all the way up to that 338 Lapua class, and then all the way down to 223. All those will be available. So in time, all those will be there. If you're a traditional press owner that can manage 1 1/4, if you have a Prezi or a rock chucker and you pull out your sleeve, those will be available in the short term, but not immediately. If you're a Zero press owner and you do not have a hybrid head, we'll run a special in the pre-order that's available now, where you can pick up your die package as well as your hybrid head at a little bit of a discounted rate. We want to take care of you guys on those.
Nice.
But all of that is available now at area419.com. And I can't tell you how excited we are for these to get into market and people to understand how good sizing can be and how consistent it can be without it having to be difficult or mysterious or this guessing game.
Yes, absolutely. Micro adjustable head spacing alone, I'm sold on this whole thing. And here's what we want to know is, what do you think of the whole concept around Zero, the Zero press, specifically the Zero M Series dies, what we just showed you? What would you use them for? What do you think of the different features that we walked through? Drop a comment and we'll start a discussion. Thank you, Craig, for coming out.
Thanks for having me, Gavin. Absolutely.
Okay, that concludes this video, and that means it's time to wrap it up. I hope you enjoyed this video. Don't forget to like and subscribe. Also, we're on Facebook, YouTube, Rumble, where we've got unrestricted content, and Instagram. Make sure to follow us on all those channels. Ultimate Reloader also has a commercial solutions division serving law enforcement, the military, and the gun industry. We have some unique capabilities, including a comprehensive suite of recoil testing and evaluation capabilities, trigger profiling, and more. If you're interested in custom rifles like what we build here on the channel or gunsmithing services, you're going to want to go to rifles.ultimatereloader.com and get on the wait list. If you're interested in becoming a professional gunsmith, check out the Sonoran Desert Institute. They've got a degree program, they've got a certificate program, and you can study from home. Learn more at sdi.edu. Thanks again for watching.